we're going to spend about 2 days just reminding you or teaching you for the first time how to simplify radicals. So what does a radical even look like? There's kind of a little girl pointing to one on a chalkboard. You know what a radical looks like? In the air, do a radical in the air. Draw a radical. Square root sign. Yeah. So you're square rooting something. You're trying to find the square root of a number. And when we simplify radicals, we're trying to kind of like reducing a fraction. Think of reducing a fraction kind of similar to simplifying a radical. We're not solving anything. We're just writing that radical in its most simple form. Okay? So to be able to learn about and use these things, we have to know what they're called. So that symbol on the outside is, of course, called the radical sign. It is so radical. The number that sits underneath the radical sign, yes, you're right, the radicand. I just think that's a fun word to say. So we've got the radical sign and we've got the radicand. You won't be quizzed over what those are called, but I will be using those words throughout the unit. So when we write those symbols on a piece of paper, we mean the square root of 16. In other words, we're saying what number could be squared and the result would be 16. And of course, it's 4. So the square root of 16 is 4 because 4 squared is 16. These right here are called inverse operations. Inverse. So squaring, I'll put an X with it. Squaring and square rooting are inverse operations. They undo each other. They undo each other. The inverse of addition is subtraction. The inverse of multiplication is division. All of those undo each other. But the opposite of squaring something is square rooting. The opposite of square rooting is squaring. Now, a lot of times my students ask me this. How are these two different? X squared equals 16 versus the square root of 16. Now, this is what a lot of students forget to do, but you guys are better about it. You guys are good about this. X squared equals 16, the solution to that is X is plus or minus 4. But then my students really get worried about this, and they're like, how come the square root of 16 is just 4? What happened to the plus or minus? And there actually is a big difference here. Now, when you square root both sides, when you solve for x and you square root both sides, when you undo these, you have to put plus or minus. When you undo a square and a square root, when you're solving for a variable, you have to put plus or minus because there are two answers created because it's an x squared. If it has an exponent of 2, it has 2 answers. So really, this is plus or minus the square root of 16, which is plus or minus 4. Now this over here, this is just, everything defaults to being positive, right? If there's no sign in front of it, we understand that it's just positive. So that's only 1/2 of the solution. So no, we're not going to write plus or minus 4 unless we're solving for x and we're having to square root exponent. All right? I know that you probably know a lot of your perfect squares. I recommend you memorize your perfect squares from 1 to 12 because it's going to help with your number sense and you're going to be a lot quicker at our quizzes and our tests. And a lot of you run out of time sometimes. You don't get it wrong, but you run out of time. So knowing these perfect squares will help you be quicker. So being able to spot those perfect squares and just take the square root of them right away, that's going to help you be more efficient. Okay? Square rooting perfect squares. This is as easy as it gets. This is like super, super easy. I bet I could teach my kindergartner this. So square root of 49, since it's a perfect square, we're not going to show our work. We're not going to do anything. We're just going to write that number that when I square it, I get 49. Now, believe it or not, students get confused and put their answer in the wrong way. Like I will see students do this as their answer. Not sure where it comes from, not sure why they do it, but they do that, and that is absolutely wrong. I can't even give you partial credit for that. If you put 7 squared, you're really saying 49, and the square root of 49 does not equal 49. So be careful that you're not doctoring up your answer at all. It's an integer, plain old 7. Square root of 25, plain old 5. Square root of 121, plain old 11. And I promise people on the quiz, in the test, they will put those numbers squared for some silly reason. Not sure. All right. Well, it's not always roses, guys. The radicand is not always a perfect square. So what are our choices when it's not a perfect square? We can simplify the radical, which we're going to spend the next 2 days on. And we'll have a quiz on Friday over it. Or we can use our calculator and we can get a decimal answer. Listen to me now. We never do step 2, option 2. We never do option 2 unless the problem gives us permission to. The default is always to have an exact answer. This one will get you an exact answer. This one gets you an approximate answer. We don't like not being perfect. We like being perfect. So we're going to do option number 1 always, unless the problem gives us permission to use a calculator and approximate our answer. All right. So now we are going to factor tree these in order to simplify them. If you remember how to factor tree, awesome. If you don't remember, I'll give you a little story to help remind you. Once upon a time, in a town called Numberland, the prime numbers developed an evil scheme to take over the world. Ha ha ha. The prime numbers, okay? Prime numbers. So the authorities took action and decided to throw all the prime numbers in jail. If you're prime, you go to jail. Okay. The jails were shaped like radicals, so we're going to call this math jail. This is not in reference to real jail. We're not talking about real jail, just our little math jail. Something happened with the text here. But the prime numbers were too smart for the authorities. They found if they could locate an identical prime twin, then together they could escape the jail. Yay! We're free! Yippee! So those prime numbers have to find a twin. But those who could not find a twin were stuck in jail forever. Aw, shucks. All right, so how does it work? You take a number, I know you already know this, and you find numbers that multiply to get 75. You find the factors of 75. You can use 15 and 5. You can use 25 and 3. When you get to a prime number, you circle it. So when I got to 3, I'm like, oh, this is prime, circle it. When I got to 5, it's prime, and it's prime. Now, the ones that can find a twin, they get to escape. Only twins escape. So the 5s found a twin. They figured out how to get out of jail. They're out of math jail. And the 3 is stuck in math jail forever. So the square root of 75 is 5 root 3. Let's try the next one. Square root of 45. What factors do you want to use? So for square root 45, we could use 9 and 5. We could do 15 and 3. I'm going to do that one this time. When you get to a prime number, you circle it. Circle, circle. Then you look for pairs. I found a pair. That one escapes jail. It's in the free world. And then this 5 is left in jail all by its lonesome. All right. 200. Let's do 20 and 10. 10 and 2. Oh, I got to a dead end. When you get to a dead end, you stop and circle it. I know there was an easier way. I'm showing the long way. I know. I wanted to talk about what happens when there's multiple people who escape jail, multiple numbers that escape. I wanted to talk about what happens. So I found a pair. I'm going to write it down. I found a pair. I'm going to write it down. And then there was one that was stuck. Now, when multiple pairs escape jail or multiple pairs are stuck in jail, you don't add them back together. You don't subtract them. You multiply them back together. So that's why I put that little multiplication sign there. So this would simplify to 10 root 2. Could you have done it as the square root of 100 times the square root of 2? Square root of 100 is a perfect square? Absolutely. Try 2 more, and don't type them in the chat yet. All right, so you can check your answers as we work these. Remember, you can choose all different factors. I could have chosen 9 and 2. I went with 6 and 3. Now, what people forget a lot of times is the number that was already sitting there. So there was already a 5, a 3 escaped, and a 2 was left over. So 15 root 2. How'd you do? Good? Next one. 15 and 10 are some choices. Neither of those are prime. Remember, you keep finding factors until you hit a prime number, like a dead end. Like nothing else multiplies to get those numbers except itself and 1. So, on number 5, there was already a 2 there. A 5 escaped. And then 2 people were stuck. A 2 and a 3 was stuck. So we need to be careful when more than one is stuck. Don't add them together, multiply them together, and put it back in math jail. So 2 times 5 is 10. Radical, 2 times 3, 6. Dun, da, da, da. All right, square rooting perfect squares. We kind of did this at the very beginning of the lesson, but now we're going to add in some variables. Remember that squaring a number and taking the square root are inverse operations. One will undo the other, just like addition and subtraction. So if I had 5 and I said 5 plus 2 minus 2, what would I get? I would just get 5 all over again. So that's because addition and subtraction are inverse operations. All right. So the square root of 9 is 3. What we can do is we can square root each term individually. You're allowed to do that. The square root of x squared. Now those are going to undo each other. Undo. Like that. That's what I was talking about down here. So the square root of x squared is just x. What about the square root of y to the 4th? So if you think about this, that's a radical sign with 4 y's underneath it. And remember, pairs get to escape jail. So how many pairs of y's are there? There's 2 pairs. I'm babying you. I know you know you can take that exponent and do what to it? What do you do to the exponent? Half it. Divide by 2. Very good. So I'm not going to draw a radical sign and draw 26 a's underneath it for you. Instead, we know that the square root of a to the 26, sorry, it's a perfect square, is a to the 13th. How do we get 13? We divide 26 by 2. If there's 26 a's, that means there's 13 pairs of a's, and pairs get to escape. Okay, what happens when it is not a perfect square? What I recommend is that you rewrite this as, I'll just put a 1 there just to show you what it's talking about, what I mean. I recommend you rewrite it as the even number exponent and then pull the odd guy out, pull them out separately, single them out. Poor z. So the square root of z to the 12th is z to the 6th. And then we have that one z who just didn't find a twin in time. He couldn't escape jail because there was an odd number. And if you're trying to find twins and you have an odd number, someone's going to get left out. So we would do this one the same way. A to the 50th times a to the 1. The square root of a to the 50th is a to the 25th. And then we have our a left over. Is that okay? All right. Here's that inverse operation hard at work again. Square root of 10 squared. 10. Square root of 1,254 squared. 1,254. The square and the square root cancel. The square and the square root cancel. Okay? Now, number 12, I put 3 stars by it because people tend to get it wrong on the quiz. A lot of people write 10 as the answer. They do square root of 5 squared, they cancel it out, and they do 2 times 5, and they get 10. But it isn't 10, it's actually 20. And you can look at this 2 ways. You can look at it as I need to distribute my exponent. Everything inside that parentheses deserves to get squared. You don't just square the root 5. You square every term in the parentheses. So 2 squared, and then square root of 5 squared. So kind of like that. So 2 squared is 4. The square root of 5 squared, those cancel, is just 5. And so that's why the answer is 20. So, number 12. Look at that one again because a lot of students get that wrong on the quiz. Future error alert. All right. Transport yourself back to algebra. Okay. What's 2x plus 3x? Yes. Ooh. Lots of people answered. 5x, of course. What's 4x plus 3y? Yes. Can't be done. So, because those are not like terms, we are not allowed to combine them. We can add them, we are adding them, but we're not allowed to combine them into one term. We were allowed to combine these because they were like terms. We were not allowed to combine the other ones because they weren't like terms. This is the same way you treat radicals. If the radicand matches, you're allowed to add them. If the radicand doesn't match, you're not allowed to combine them. Okay? So, let's take a look at this. 2 root 3 plus 5 root 3. That's just like saying 2x plus 5x. What would you write? You would write 7x. Well, instead of putting 7x, you're putting 7 root 3. You don't do anything to the root 3. You don't add the radicands. You don't change it. You just add the coefficients. It's like I had 2 apples plus 5 apples. I have 7 apples. Just because I combined them, it didn't change the kind of fruit. You don't change the root 3. Next one, 4 root 5 plus 3 root 7. Well, those are not like terms. Therefore, I can do nothing to simplify that expression. All right, these are the last 2 problems. I want you to work on those by yourself first. All right, let's work these 2, and we are done. So we simplified this earlier. Do you remember that? It was 3 root 5. So I'm going to go ahead and use that knowledge from earlier in the lesson. I remember, sorry, that was 5 root 3. I'm writing numbers backwards now. So since we already factor treed this earlier in the lesson, we are allowed to use that again. So this is really saying, let's combine these, that's 10. So this is saying 5 root 3 plus 10 root 3. Those are like terms. We're allowed to add them together. And final answer, 15 root 3. Is that what y'all got? Yay! All right, next one. We're going to factor tree 4 times 2, 2 times 2. The 2 escapes. So I'm going to put the 2 on the outside and keep the other one in jail. So far I've just done this one. Now let's do this one. Let's see, I can do 9 times 2, 3 times 3. So there was already a 3 there, then a 3 escaped, and a 2 is left over. And then this guy is already simplified, so we don't need to do anything about him. All right, let's clean this up. We've got 10 root 2 minus 9 root 2 plus root 3. So now we can write our final answer. 10 minus 9 is 1. So that huge expression, turns out all along it was just square root 2 plus square root 3.